Hello and welcome to Education at SSBJ online video tutorials. We will continue with the demonstration of Ohm's Law and learn how to do this practical when these materials are given in your hand. In the previous video, please recall that we have learnt about the device voltmeter. We had 2 voltmeters and we have learned how to find out the least count of the voltmeter. Please refer the previous video. Then we learnt about the resistor. I had opened this and showed it to you. I had also showed the actual resistors which are of different values. Right? Please go through the previous video before you start this video. Right. We have written certain pages. We started with Ohm's law and we learned what is voltage and current, the symbol which is used, right? And this Ohm's law is to state the relationship between a current as well as voltage. And then we found how to find out the least count of voltmeter. Right. Now, the other items which we are using in this demonstrations will speak on. So what is there in front of you is a rheostat. And what is rheostat? Rheostat is a resistance, or you can call it as a resistor. Suppose if I can place a white paper and below the rheostat I can write a few things about the rheostat. Right? As I said, rheostat is just like any of the resistance which I have already told you. But there is a slight difference. Okay, the value of the resistance here in this resistor is fixed. So this has a fixed value. Okay, and also this has a fixed value. You can see here 270 ohms. So this is also having a fixed value, constant value. Whereas the rheostat, which is also a resistor, or you can call it as a resistance, has no fixed value. You can change the resistance of this device, right, by moving this head. Look at this. I am moving this head. So it is called variable resistance or variable resistor. You cannot vary this resistance unless you cut this coil. Okay, but here we can move this head of the rheostat and vary the resistance. Its value can be changed, right? And therefore, if you can give a symbol for this, this is the symbol of this resistor, and also this. Okay, both can be given a symbol here, but whereas this resistance has a symbol this way, right? So this is the symbol of this resistance, which is called rheostat. You can read this, rheostat, which is a variable resistance. This represents the head. You can move this and change the value of the resistance. Now, can you tell me why when we move the value changes? You have already learnt in the theory that resistance depends on the length of the conductor and also the thickness of the conductor. For example, more thicker the wire, resistance will be less. Okay, shorter the wire, more the resistance. It's a property, resistance is the property to oppose the flow of current. Right? In the same way, if there is a thick wire, then it is easy for the current to flow. Right? The resistance will reduce. Okay, but lengthier wire has more resistance. So I hope you have understood what is the variable resistance and what is the fixed resistance. Right? Now in this experiment, we are going to actually calculate the resistance of a given resistor by using Ohm's law. Right? As we have already seen in the previous video, Ohm's law is a relation between voltage and the current. Now while developing the relation between voltage and the current, we will be finding out a resistance of this resistor. Right? So we'll go ahead. Since we have studied about voltage in the previous video, let me tell you about current and how can we measure them. The device which is used to measure current is an ammeter. Okay, so I am going to show you ammeter here. This is a ammeter. Now look at these two ammeter. Right? Here it is written A. Right? And in this device it is written MA. Well, this will give you a readings. Right? This will give you a reading in milliamperes. Right? Whereas this ammeter will give you a reading in amperes. And what is ampere? Ampere is the standard unit of current, like how volt is the standard unit of potential difference. Ampere is the standard unit of current. And why should we use milliampere then? Sometimes our experiments demands a very small value of change in current, and that is why we use many a times milliampere. But when you take down the values from here, you have to convert that value into ampere, because ampere is the standard unit of current. Okay, now how many milliampere is equal to 1 ampere? Remember this, 1000 milliampere is equal to 1 ampere. This is the relation between ampere and milliampere. Now before we go for the experiment, as I said you already, that we need to find out the least count of this. Any measuring instrument, we have to find out the least count first. Like how we have found the least count of voltmeter. Right? Let me once again demonstrate finding of least count of all the three. Okay, we'll do it once again, and then if time permits, we'll do the circuit and start the experiment, or else we'll go for the part 3 of this video. Okay, so I'm going to replace this with another white paper. Here it is, so that I can write freshly. Okay, now coming back to the least count of this voltmeter. And how can we find the least count? But before that, voltmeter is the device to find out the potential difference. That is voltage between the 2 points. Okay, so please remember that if this is the symbol of voltmeter has got positive and negative terminal, and this should be always connected between the conductor, between the two ends of the conductor, like this. That is almost like a parallel, so that it will find out the voltage between two ends of the conductor. So it has to be connected across the conductor, right? So now let us talk about the least count. How to find the least count? You have to find the first value here. It's a 0, and from 0 to next value is 0.5 volt. Please remember, it's not 5 volt, 0.5 volt. And find out how many divisions are here. There are 10 divisions which are there in between. So 10 small divisions. So let me write 10 small divisions is equal to 0.5 volt. Right? So what does one division gives? So one division will be equal to 0.05 volt, which is because 0.5 divided by 10. Right? So that is the value of one small division here. And that is what is the least count. Right? So we have found the least count of this. Right? Not all voltmeters will be of this type. Sometimes, as I said you, voltmeter also can be of this type. And now if you can find out the least count of this, the first value is 0 and the next value is 2 volt. It's not 0.2 now, 2 volt. So how many divisions here? 10 divisions here. So 10 division gives, so let me write here, 10 division equals how many volts? 2 volt. So 1 division will be equal to 2 by 10 is equal to 0.2 volt. So here the least count of this is 0.2 volt, whereas least count of this voltmeter is 0.05 volts. So it depends on the type of voltmeter and the range of the values mentioned in that voltmeter. Right? In the same way, we'll find out the least count of the ammeter. Okay, and why is ammeter used? Ammeter is used to measure the current. Right? And how is that connected? For example, as I said you that voltmeter is connected across the conductor, whereas ammeter will be connected in series with the conductor. For example, let's say this is the conductor or a resistance or a resistor. Okay, and now suppose if you want to find out the voltage, then you have to connect voltmeter here, right? And then you are supplying some voltage to that conductor. Here I am going to connect this, but then how much of current it is supplying, that we have to measure with the help of ammeter. Now you see, ammeter is connected in series, whereas voltmeter is to be connected across the 2 points of the conductor. Right? And then after that you can connect many other items. Right now I will be connecting one switch and finish it. Okay, this is the positive of the battery, this is a negative of a battery, or you can call it as a cell. Particularly it is cell here. I have taken only one cell. So if this is a positive, please remember that this end of the ammeter also should be connected to the positive. This is very important point of this practical. Now further you go, if this is a positive, then continue this end. So this end will also be positive. So positive to positive for the ammeter and positive to positive for the voltmeter. This is the way you have to conduct. In case if you miss this terminals, what happens is, suppose you have not connected properly as per what is said here, then instead of this needle moving front, it will be moving back. So you can correct it afterwards. In the same way, if you connect it wrongly, then instead of moving this needle front, it will move backward. So we will not be able to measure. Right? So ammeter should be connected in series with the conductor. So if you can write I as current, so current moves all around the circuit here, which is measured by ammeter. Right? Now coming back to the least count of this device. Right? So again the same method. We have the first point is 0 here, then here 0.2. So between 0 and 0.2 we have 10 small divisions. Okay, so let me write 10 division is equal to 0.2, and therefore 1 division is equal to 0.2 by 10 is equal to 0.02 ampere. Right? So this is the 0.02 ampere is the least count of this ammeter. Right? Now let's go for this. What is the least count? Here from 0 to 100, 100 what? 100 milliampere. Right? It is 0 to 100 milliampere. That's why, see how many divisions are there? 10 small divisions are there from here to here. So 10 divisions is equal to 100 milliampere, and therefore 1 division is equal to 100 by 10, which is equal to 10 milliampere. So one small division gives us the value 10 milliampere. Right? So what is the least count of this? 10 milliampere. Right? So this is about finding the least count of these two devices. Okay? Now coming back to the last one, rheostat. As I said, rheostat is given a symbol like this. It's a variable resistance. Right? So how will you connect? This will be connected. One end you have to connect here, another end will be connected here. So here you can see one end is here, another end is here, to make it variable resistance. Right? If you want this to be used as a variable resistance, resistance value should change. 1 ohm, 2 ohm, 3 ohm. Then this here one connection, here one connection, you keep moving, it will change. Right? So next period we shall connect all these and use this resistance, find out how much is the voltage developed here, how much will be the current, and find out the relation. And how will you change the voltage? By changing the resistance. Right? You will exactly come to know what we have to do. But please go through both the videos, because unless and until you go through both the videos several times, when you enter into the physics lab, when the same things are given for you, then you get confused in connections. Right? So thank you very much. We'll wait for the third video to come. God bless you all.